Okay, so since we are landed on this website, last time, if you remember, we just did some administrative stuff and started getting you excited about Python, what it was, the difference between Python, Jupyter Notebook, Anaconda, PyCharm, etc. And again, you can see all those slides over here. You can click on the Python primer, for example, and it will just download, you can just download those slides, print them, whatever you want to do. Okay. Now we're going to go over these easy Py slides. And you will notice there's a cliche with Python things. Everything has a Py appended to it, numpy, easy Py, campy, whatever. So it becomes like a sort of a cliche, but we like it. So this is actually a Jupyter Notebook that I converted into slides, and you can do that in like one shot. That's a little bit advanced feature in Jupyter Notebooks, but not only can you use a Jupyter Notebook as a Word document for a report, you can also turn it into a presentation. And that's exactly what I did with this notebook. So today we're gonna go over a very lightweight introduction to Python. I am of the opinion that we should not separate programming courses from technical courses and engineering courses. Rather, we should learn, for engineers, I think we should learn coding and programming, coding specifically, in situ, on the spot. So driven by a need, okay? So that's why I don't like learning programming in a course and then coming to numerical methods and you learn in numerical methods and you're like, what can I use from what I learned before? So what I'm going to adopt in this course is an approach where we learn complexity, we learn Python as needed. However, we just need a basic baseline that we can start off with, okay? And this is the basic baseline, all right? So some of the things I'm going to cover here I already talked about, but I'm going to talk about those again just to reinforce those ideas. This is an easy guide for learning Python. You don't need more than this to get started. Once you get familiar with basic syntax, then you can start digging deeper on your own. There's no way to cover all of Python. The basic Python has probably just a few hundred keywords. Everything else that people do with Python is based on using libraries. Like if you're doing data analysis, you use pandas. If you're doing numerical analysis, you use numpy and scipy. If you're doing a lot of symbolic math, you use sympy. I cannot cover all of those libraries. It's on you to figure out what your needs are and then dig into specific libraries. But the basic functionality of Python is just very lightweight, and that's what we're going to try to cover today. Now, I explained to you my attitude about programming, and that's essentially to articulate what you want to do. Say, to compute a Taylor series of a function, I need to add a bunch of terms, for example. To add a bunch of terms, I need to do a for loop. Therefore, how do I do a for loop in Python? That would be the essence of how you would approach solving a problem, especially if you don't know, if you're new to a programming language. Like if I forgot everything about MATLAB. Now, if I have to do something in MATLAB, that's what I would do. I would just, how do I do a for loop in MATLAB? Okay, how do I calculate, a norm of a vector in MATLAB? Okay. As an engineer, I think programming languages are fundamental tools in our arsenal to tackle research problems, but they're only a means to an end, okay? You don't have, the goal is not the programming, the goal is to solve the problem. So you learn as needed. And a key reference for this guide is given here. You can look it up. I think it's available free online. But it's a little bit, again, it defeats my approach to learn as needed, but it's a pretty good reference if you like it. So I showed you this picture last time. Anyone can code. I trust that all of you can learn to do basic coding. Okay, we explained what Python is. It's a programming language that promotes productivity, and I cannot stress how important it is for you to know programming, not only to give you a competitive edge. This is your age, and whatever generation you're called. I'm a millennial, you're probably Gen Z or whatever comes after that. This is the age of computers. This is the age of talking to computers. You need to be able to communicate with computers, and more programming languages are becoming easier to use so that you can communicate with computers, and Python is one of them. Um, and this is a great example I like to give about Python, and it's from a movie called Hidden Figures. Who has seen that movie? Yeah. Okay, so can you tell us about the movie? Just briefly, yeah?
So this is talking about the space race, and it follows these three women that worked at NASA
Yeah.
and did all the computing and all of like the calculations of how we get better orbits and how we
Yeah.
get into the moon.
Yeah, yeah. It was 1962, and John Glenn was the first American to go to space and orbit the Earth for 2 or 3 days. And there was this group of women. They were called computers, actually, because they computed trajectories and they integrated equations. We're going to learn about those equations by the end of the course, but they did integrate Newton's law to calculate the trajectory of the rocket that was going to go out into outer space and release the capsule with John Glenn in it. So let me show you this clip, and then we'll discuss what. No, that's the wrong. Let's see. Which one did I use last time? Okay, this is good enough. You may not be able to hear the audio. Okay. Let's see.
What's it going to take to make this thing worth the price tag? Well, we're just getting up to speed here, Mr. Harrison. I need more manpower. I need programmers, folks to feed the cards. We'll get them to come out loud. You're the IBM man, right? Yes, sir. Well, we'll pull Miles Guy if you have to. Understood? I'm not paying any of you.
When the first IBM came to NASA, it was not an easy transition.
And what about to measure these things? I'm afraid not, sir.
Nobody knew how to use it. Computers were these big units that took up the whole entire wall.
There's more computing power in a toaster today than what was available to these people in the 1960s.
When Dorothy sees the IBM being built, she learns how to program them.
She realized really quickly that the IBM was going to be the way of the future.
The IBM 7090 data processing system. It has the ability to solve problems that cannot be solved in a lifetime of manual labor.
What's your name again?
Dorothy Vaughn.
We need the IBM for Glenn's launch.
We got a job to do. Whatever happens up there, it's in God's hands.
My guys are ready. They can do the work. Ladies, we've been reassigned.
She basically saved her whole team's jobs and created a value for herself.
It's so funny what we think of as computers now and what they were then.
Okay. So what actually happened then? They brought in this IBM data processing system, and the only way to program it was through Fortran, I believe. And Dorothy and her team had to learn Fortran. It was like the Python of today at the time. It was like this new thing, and they had to program with these punch cards. It was miserable. So don't complain about programming today. It's much easier today. You just click a button, click enter, and just it works. So anyway, we live in a very fortunate age. Anyway. Okay, so this should be inspiring. It certainly is inspiring to me. Still inspires me. I have a list of movies that I like to watch every year. Anyway, this is one of them. Okay, why you should learn Python. We talked about that last time. Now, obtaining Python. Some of you, again, you don't need to install it locally if you plan on using the Jupyter Hub, juno.chpc.utah.edu. If you want to do that, forget about this slide. But I guarantee you at some point through the semester, as you become more proficient, you're going to want to have a local installation of Python on your laptop, and where you can also use Jupyter Notebooks locally on your laptop. My favorite way of getting Python on your laptop without any hiccups is to go to the Anaconda project, www.anaconda.com, and just go from there. Just download the installer. It will install everything for you, and it will show you how to start a Jupyter Notebook, and you'll have Python running, no issues. Again, and it's all free. Okay. Executing Python code, there are a few ways to do Python code. The traditional way, for those who love kind of more of the shell-based approach, like Linux programmers, etc., that you write your code in a Python file, and you just give it the extension py, to say, hey, this is a Python file. And you simply execute Python, my Python code or the Python file, and it will run it in the shell. A higher level way is to use an integrated development environment. I mentioned those last time, like PyCharm or Spider, where you have your code on the side, you can debug, you can run it in the IDE. Now this is very useful if you have a large project in Python, like you have hundreds of files, and you're dealing with them. Jupyter Notebook doesn't work that well, so you should use that method. But for the intents of and purposes of this course, you don't need that. Some of you want to do this, feel free to do that. And finally, using the Jupyter Notebook, this is my favorite approach, at least for kind of, just learning and prototyping things, because there's no barrier. You just open up a browser and you just write text, take notes, take notes of what you're doing, and, explain to yourself what you're doing, and then implement the code and run it, okay? Now, I mentioned last time that Jupyter Notebooks have two types of cells, a text cell and a coding cell. The text cell, you can just type text, but you can also do kind of fancy things. What if you want italics? What if you want boldface? What if you want red? What if you want a heading? You can do that by using something called Markdown. Markdown is a programming language for displaying text, okay? But it's very easy, and there's a Markdown cheat sheet. If you remember last time, I showed you if you put a certain symbol for heading, the sharp symbol for heading, it gives you like heading 1, and then if you put 2 of those, it gives you heading 2, and so on. So there's a Markdown cheat sheet. If you click on this link, it will hopefully show you kind of, yeah. So if you do this, for example, this is, if you use the sharp symbol for heading 1, heading 2, heading 3, heading 4, heading 5, this is what it will give you. And there's a bunch of things. If you want to do a list, like a bulleted list, this is how you would write it, okay? And when you execute it, this is what it would look like, okay? All right, so I'll leave that for you to, where's my cursor? For you to do, okay? Okay. Next, so Python has just a basic core functionality that I said, we can cover very lightly. We start with variables. If you want, right now, go on to juno.chpc.utah.edu and follow through with me on these slides, or you can do that at home, whichever you prefer. I say you do it right now if you can. So go, if you have a laptop, just go on juno.chpc.utah.edu. That's juno.chpc.utah.edu, and log in like we showed last time. And then create a new, let me do that with you right here. Okay. So juno.chpc.utah.edu. Of course, it's very slow. If you're still having problems accessing it from home or from the ICC, please let me know. Just email me, and then I'll talk to CHPC. Maybe we can create an instance specifically dedicated to this class. Okay? You guys still waiting? Okay. Okay, let's say, it's not working now. You can try it at home. Okay. We start with variables. To do things in any programming language, you need to store values in things, right? And we call these variables, okay? Just like with any programming language, variables are declared and assigned on the spot. So for example, over here, I declared a variable called myvar, okay? And I assigned it on the spot a value of 33. So myvar is an integer value in this case. And then I print myvar, and this is how you print something so that you display it on the screen. So you learned two things in this statement. Now you learned how to declare a variable and assign it a value, and also how to print a certain variable. Now, the cool thing about Python is that it automatically detected the type of this variable as an integer. It assumed that it is an integer because we did not give it a decimal point. So in higher level, in other hardcore programming languages like C and C++, you have to declare the type of the variable. You have to say integer myvar equal 33. for example, or float my var equal 33.0. Okay, with Python, it will automatically detect the type of the variable. Now, however, if you multiply a variable by a floating point number, like this one, 3.0, then Python is going to say, hey, this is an integer times a floating point number. I cannot return an integer. I'm going to return a floating point number. And it automatically makes B a floating point number. Okay, so you will see me every time I'm doing numerical methods, I'm probably using numbers with decimal points. You will see me declare variables with a decimal point at the end, 0.0, to tell Python to enforce the idea that this is a floating point number. The risk being, if you don't do that, and you happen to be doing a division between two integers, then it's gonna assume that that division is an integer division, and it's gonna round it. Okay, and you don't want that when you're doing floating point arithmetic. Okay, we'll get to see those issues later through the course. So the ability of Python to detect data types of variables is called dynamic typing. Okay, so let's see here. Okay, so this is probably the page you're looking at. You go and create a new Python notebook and say, call it EasyPy. Okay, and then just type in my var equal 3, and then print my var. Okay, it printed it, and then if you declare my var 1 equal 3.0, okay, then print my var 1, then it will assume that it is a floating point number. Okay. All right, so feel free to follow through as I go through these slides. Strings, and you may ask, why do we need this data type? But what are strings? They're essentially text. They're variables that store text in them. Why do we need that? Well, we need that sometimes to store certain titles of certain things, of certain arrays. You will find that storing strings and manipulating strings will be helpful for you as you output results from your data, as you combine results from different data sets that have different titles. You need to be able to manipulate strings. So strings are created simply by using double quotation marks. So str1 is equal, this is my first string, so I declared a variable called str1, and I immediately assigned it the value. This is my first string, and I put single quotation marks here, or you can do double quotation marks. Okay, so go ahead and try this. And note my approach to naming variables. Typically, I like to append the type of the variable, especially if it's a string. I like to append a hint to what this variable is, what type it is. So, if I would append the word str to variables that contain text, so that I remember that this is a string variable. In a typical notebook, you may have thousands of variables, and you want to be able to just essentially immediately infer what data type this variable is. So it's just good programming practice. Okay, now the cool thing about Python is that you can add variables together, even if they're of different types. It may give you an error, but it will at least try to do it. So in this case, what's so cool is that you can add two strings together. Now remember, str1 was, this is my first string variable, and there was a period. And then str2, this is also another string. Now if I add those two, okay, and store them in another variable called str3, then it just adds them. It gives you another string that contains, this is my first string, period. This is also another string, okay? And you can also add extra strings in between. So if you notice here, it would have been nice if I had a space over here and a period at the end. So I can do that. I declare another string variable, and I say string1. Remember, this string1 contains these things here. This is my first variable, period. Then I want to add a space after that. I simply do plus space, right? So this is a string, correct? It's a string that contains a space in it. Plus string2, and then I add a period at the end, and this is what you get. Okay, you see the string that we added over here, the space, and the other string that we added here that contained a period. Okay, strings represent what we call an immutable list of characters. So the way Python interprets a string or a text is that it stores every character of that text as an array. So when you said str1 is equal, this is my first string, it automatically behind the scenes created an array that contained t, h, I, s, space, etc., etc. So it's an array of size, I don't know, 23 characters, right? Where each entry in the array, and I'm assuming you know what an array is. It's like a vector. It's a list of things, okay? It's a list of things. And so strings are automatically arrays, but they are immutable in the sense that we cannot manipulate them. Once you declare a string, you cannot go and change a value in the array of that string. Does that make sense? So we created a string called this is my first string period, and that created an array that contained all the characters of that sentence. Now I cannot go after that and say I want to change one of those characters. Okay, so let me prove this to you. So okay, let's say str1 is my first string. Okay, now if I do str1 and 0, this is accessing the first entry. So this is MATLAB notation as well. Okay, this is accessing the first entry in the string 1 in the str1 variable. Now because str1 is actually an array, you can access the elements in that array by accessing the indices of those elements. In this case, the first entry in the array at index 0 is m. The second one is y. Okay, so str0 is m, str1 is y, str2 is a space, and so on and so forth. Okay, but you cannot go ahead and say, hey, I want to change this value to a period, for example. It's gonna throw an error. Why? Because strings are immutable objects. Are you gonna need this? Well, no, but this is more of a segue for me to introduce ideas like arrays and mutable and immutable objects. Okay? Okay. So now another thing that is useful in strings is that you can loop over entries in the string. And more on this for loop later, but essentially because the string is an array, you can loop over entries in this array. And I will teach you about this style of looping in Python. I told you last Tuesday that you can do a for loop in 2 lines in Python, and this is how you do it. This is called an iterator loop. We will talk about this once we get to loops. Okay. Okay, so now we introduce the idea of an array, which a string automatically creates an array. Oftentimes, in numerical methods and in all computing, you need lists of things because you're not dealing with 1 or 2 objects. You're probably dealing with thousands of objects. And you don't want to go and access one object at a time and put every object in a variable in itself. Rather, you want to create one variable and store all the entries, all the data in that one variable, and then manipulate that data by looping over it, by adding things to it, by multiplying it with other things, etc. So we're starting to get into arrays, or what we call also lists or tuples in Python. So Python offers, basic Python without any library, offers 2 types of lists or containers. Okay, so think of these data types as containers. What can you do with those containers? You can store a vector. So if I give you in the future a vector field, you know, a vector of data, you can store that vector in any one of those 2 data types that I'm going to introduce now. The first one is called a tuple or tuple or tuple. A tuple is an immutable sequence of arbitrary objects. Okay, they don't even have to be of the same type, but the caveat is that it is immutable. And these objects are declared by separating them by commas and enclosing them in parentheses. So let's say you had certain data that is given to you by 1, B, and 2. You have this sort of data. Maybe you're doing DNA sequencing, okay, and you have numbers and strings, okay, and you want to store those in a variable. So this is how you would do it, okay. Now this is actually a type of array, just called a tuple, okay, and you can access items in a tuple simply by indexing that's said tuple. So let's do an example. Okay. Let me just Make this go a bit higher over here. Okay, so A is a tuple. Okay, so I'm gonna put entry 1, and then 1, and then entry 2, and then 3. Okay, so now this is essentially an array of 4 elements in it. Okay, to access data in that array, you simply access the index of that array by using the bracket. So A0 would give you entry 1, A1 would give you entry the number 1. Okay, so Python is we use 0 indexing in Python by default, as opposed to MATLAB, which uses indexing of 1. What does that mean? Means that the first index of the first entry is 0 in Python. The index of the first entry in MATLAB is 1. That's it. So just bear that in mind, okay? So to access the first entry in an array, in a tuple, in a string, in anything Python, the index of that entry is 0, okay? Makes sense so far? Any questions? Again, you don't see any use for this, but we have to start somewhere, okay? Just getting you familiar with these things, getting you, to type some text and see some results, okay, in your Python. But you cannot type things in a tuple because tuples are immutable. So similar to the string situation, you cannot go and say, I want to change the 4th entry in A. So you cannot change the last entry in A in this case, okay? Well, there's a mistake here because this last index should be actually 2. Okay. All right. Lists. Now, lists are like tuples, okay? They serve the same purpose. They are just an array. However, they are immutable. You can manipulate them. You can change them. And that's something that we want to do because sometimes we are working with data that we want to change and update. So if you create an array that is immutable, you cannot change it. What's the point of it? Okay? So we want to be able to create arrays, lists, okay, that we can modify and manipulate in situ. And lists serve that purpose. So they are defined exactly like tuples. However, you use brackets, okay? So this is how you define a list. So it's the same implementation as the tuple. However, you use brackets. And also you can access lists the same way you access tuples by saying, my list 0 will give you the first entry, my list 1 would give you the second entry, and so on. But the beauty of lists is that you can modify them. Okay? So in this case, what was my list? My list had a B in the end. I want to change this B to an A. This is what I would do. I would go my list, where is that A located? It's in the index 3, and I change it to A, and I'll print my list. This is what happens. So let me show you in real life. Okay, so if I change this, so let's say A is 1, 2, 4, C, and then H, okay? Now, again, accessing the array, accessing the list is just basically indexing. A0, A1 gives you this entry. And so this has 1, 2, 3, 4, 5 entries. So the last entry is at 4. Okay, so that gives you H. But I can change now. I can say I want A4 to be equal to D. And it allows me to do that. Now I print A, and it gives me 1, 3, 4, C, D. Okay? So we changed an entry in a list. Okay. You can append items to a list. Now this is also useful in certain cases when you don't know the size of your data. If you're going to be increasing the size of your data, again, let's say you're computing a Taylor series and you want to add more terms to your Taylor series and you want to store the error committed by adding every term. Okay, so your list of errors is going to depend on the number of terms. And if you don't know how many terms you're going to be adding, you need to add those on the fly as you are computing. So lists are really cool that way because you just create a list and start adding things to it. You create an empty list and start adding things to it, okay? And simply what you do, you take the list variable and say dot append and just append a value. So in this case, our initial list only contained 1, 2, 3a, and then we appended the number 43 to the end. Okay? You can also insert items at a specified location in a list. Okay? So this it uses the word, it uses the function insert. You give it where you want to insert it, or after, at what index you want to insert this item, and you insert it. So if you think about this, my list, what is the indexing here? This is index 0, index 1, index 2, index 3. We just inserted item at index 3. Okay, so it made it, yes?
As far as appending goes, is there a chance we can accidentally like set our program in an infinite?
Yeah, and then you have to crash it. Yeah, so you have, it will, you just have to kill it. Yeah, it always happens, right? Yeah. Okay. Now you can create, now remember, lists are containers that can contain arbitrary things. And so lists can also contain lists. And lists and lists and lists. And why do you need lists of lists? You would need that to create multi-dimensional arrays. Okay, so if you want a list in the x direction, a list in the y direction, a list in the z direction, you would create 3 nested lists inside of each other, and gives you a big array. Yes. So we'll talk about that later. Okay, what we're gonna do for lists of lists, we're gonna use numpy arrays, and pulling out elements from a list of lists with numpy arrays is much easier than doing it with standard Python lists. Okay. Okay, so this is, for example, a list of 3 lists. And for example, this could signify a matrix that contains the elements 1, 2, 3, 5, 7, 8, 17, 0, 9. So I type this in a way that looks like a matrix to enforce this idea in your mind that I'm storing 3 rows of the matrix in a list. And each row is a list in and of itself. Okay? You can create an empty list by using just empty brackets like this. Okay? So you create X as an empty list, and then you start appending things to it. So this would be useful, for example, if you are storing the error, doing a for loop over, these are questions that are going to show up in your homework in the future. I may ask you to compute the error of using, using a certain formula and successively, varying one parameter, and I want you to plot the error as you vary the parameter. So how do you store that error? You can create an empty list and just append the new error to it as you go along and do your calculations. Okay? For scientific computing applications, we want to use numpy arrays instead of lists. We will look at numpy arrays once we get to linear solvers. However, numpy arrays will only store numbers. Okay, you cannot store, will only store numbers. You cannot combine numbers and strings, or you cannot store strings in numpy arrays, because the numpy library is specifically for numerical manipulation. Okay? All right. Here's a little warning. This may not make sense to you, but it is something that many students fall victim to. If B is a list, then the assignment A equal B, you would think that this will create a new variable called A, okay, that contains a copy of B. However, this is not the case. When you say A equal B, it doesn't create a new copy of B. Rather, think of A and B as 2 variables that point to the same location, to the same data in memory. Okay? So again, when you say A equal B, you would be thinking that, hey, I'm just going to create a copy of B, a temporary copy, and do something with it, but I don't want to lose the original data in B. Well, be careful. A equal B does not make a copy of B. Rather, A and B will be following the same data in memory. So if you change A, B will change too. If you change B, A will change by the same way. Okay? So this is called pointers. This comes from C and C++. So let's see an example. Okay? So let me make an example over here. Okay, let's see what I used. Okay. Okay, so let's create this array. Okay, A equal 1, 3, 4, and then, or let's say A equal 1, 2, 3, 4, and then B is equal to A. So print A is equal, okay, A, and then print B is equal B. So now A and B, they are equal, okay? Now you would think that if you change B, then you're only changing B, but you're not changing A. Okay, so let's see what happens. So let's say B of 1, I'm gonna put it 30 to 33, and then we print B. Okay, this is what B is. So this is B equal. Now let's see what happened to A. Print A. See, A changed as well. We changed B, so did A. Okay? That's because A and B are what we call pointers. So the location in memory that stores 1, 3, and 4 is a single location, and A and B are actually live in different locations in memory, but point to 1, 3, and 4. So if you change one of them, you change the original data, because the other one points to that same data, it's also going to change. So now the question is, how do you make a hard copy of A? So let's say, I don't want to touch A, I want to create a temporary variable so that I can manipulate and I want my original data untouched. You do a hard copy, and that's by saying, you do, so let's go back here, okay, and you do, rather than doing B equal A, you do B equal A dot copy, okay? So now you change B, but A remains unchanged, okay? So what we did when we did A dot copy, we took these entries 1, 3, and 4 and made another copy of them in memory and created another variable B that points to that in memory. Just be careful. This applies to pretty much everything Python, all variables in Python, okay? Not just to lists. Okay. If you want to make a copy, you just do b.copy. Okay, displaying variables, you kind of saw that. You can just type the variable in the Jupyter notebook, and it will just press shift enter, and it will show it. Or you can use print, and we saw that. You can also format a string using print. You can just mix text and variables. We can spend a full day on looking at how you can format things with print. I leave that up to you, depending on your situation. But basically, you will not need more than this, printing text and a variable next to it. And you can put multiple of these things. So you could say, for example, let me see, you could say print A equal A, and then B equal B. Okay? And if I want a new line, for example, I can use the carriage return, which is essentially /n. There you go. Okay? Anyway, so don't worry about this for now. We can learn about it as needed, and you'll see me do some of these things in class, so you'll start picking up as we go along. Okay, Python supports basic math operators, and the great thing about Python is that you can pretty much use these operators on pretty much any variable type. So you probably have seen if you've done C programming or C++, you probably have seen that you cannot add two arrays to each other. You have to loop over the arrays and add the elements pointwise. In Python, that's not the case. So if I take two lists, I can pretty much just add them to each other. If I take two numpy arrays, I can multiply them or add them, etc. Now, what does that mean? It depends on the type of variable, right? So if you have a 2D arrays, in NumPy, multiplying them, what does that mean? Is that an inner product? Is that an outer product? We'll talk about these when we get to linear systems. But at least you can apply these operators. You can do addition, subtraction, multiplication, division, exponentiation. So if you not take a power, so if you want to do 2 to the power something, you just do 2 stars, okay? And if you want to take the modulus, you use the percent, so that gives you the remainder. You can also use augmented assignments. So this is just a fancy little shorthand for updating variables. One of the key things in programming is that you often see this assignment. You see A equal A plus B. What does that mean? So let me say, okay, let me give you this example. Okay, let's say you will often see us do, so let's say I have a counter and the value of the counter is 3, and then I say, so the value of the counter I is 3, and then I say I equal I plus 1. Okay, and then print I. What do you think I is going to be? 4, right? Okay. But remember, this is not a mathematical operation. Okay, this doesn't make sense mathematically, I equal I plus 1. What this is saying is, on the left-hand side, I have new memory, okay? I want to update the memory. And on the right-hand side, I have old memory. So when I say I equal I plus 1, I'm saying the new value in the memory is going to be equal to the old value in the memory plus 1. That's it. Now, there's a shorthand for this. And rather than doing I equal I plus 1, you can just do I plus equal 1. Okay? It's just a little shorthand. You can do it with multiplication, with division, and with subtraction. Okay? And with the models. Now, we also need to compare things. So for example, in the once we finish with these slides, we're going to start looking at error analysis. As we construct certain functions, we need to keep approximating those functions or the solution to a certain problem until we reach a certain error or tolerance threshold. So how do we detect that threshold? We need to say, as long as the error is greater than the tolerance, keep on doing things. So we need a greater than or equal or greater than or less than and less than and or equal. So we need these types of inequalities. And just like MATLAB, C, and C++, Python provides you with a bunch of things. You have the less than operator, the greater than, less than or equal, greater than or equal to, and not equal to. And those are most often used in conditional operators, which we will talk about in a couple of slides. Okay? Now forget about this here. Okay, conditionals, if statements. One of the most important foundations of any programming language is its ability to compare things, to compare two values, okay? And you can do this with what we call conditional operators, and that's the if, else statement. And that standard statement goes as such: if condition, do something. So if condition is true, do something. Else if condition 2 is true, do something. Else if condition 3, do something else. And finally, else if all other things fail, just default to this condition. Okay? Now, you don't have to have this entire statement. Every time you have an if statement, you can just do if A greater than B, then do something, and that's it. But if A greater than B, then do something. And then else if A greater than 2B, do something else. And then else, do something yet even cooler or whatever. Okay? Now, the key thing with Python is indentation. So that's one of the annoying things about the Python language, is that you have to indent to define your scope. Okay, so how can I tell that I am under this condition? I have to indent the statement that is under the condition. And you can indent, you have to adopt one indentation style from the beginning of your notebook or of your Python code. You can use a space or a tab or 2 spaces. I always use a tab, okay? Because the first indentation the Python interpreter is going to adopt that as your indentation style. Okay, so always use a tab. Just use a tab, and forget about forget about it. But this will define your scope. Okay, so if you notice here, no indentation for the if statement, for the if condition. But then, you know, if this condition is true, what do? I indent everything I want to do when this condition is true. And then when I go back to outside the condition, I, you know, remove the indentation and so on. Okay? So here's an example. Let's type it together. Okay, let's just try to typeset it. Okay, say A is equal to 3, and then if A is less than 0, okay, now notice how Python automatically indents for me. Print the number is negative, okay, and then now else if A is positive, print the number is positive. The number is positive. Okay. Finally, if it's neither, else print the number is 0. Okay. So let's do -3. The number is negative, and let's do 0. The number is 0. Okay. Any questions? Yes. Shift enter. Shift enter to run. Okay, you have to type enter. Okay. All right. So let's go a little bit faster. I want to finish this in a few minutes. Okay. So loops. So the other foundation in any programming language are loops. You have, because we're dealing with the benefit of using computers is that you can deal with large quantities of data. And to go over those large quantities of data, we need to kind of loop over them very quickly. So there are two types of loops in pretty much any programming language. Those are while and for loops. Okay, we will start with while loops. The while loop essentially is a for loop. I should have inverted the loops. I should have introduced for loops first and then done the while loop. But essentially, I think you know what for loops are. While loops are essentially for loops plus a condition. Okay, so what you're doing with the while loop is you're saying, think about it in terms of just words in English. While the error is greater than my tolerance, which is 10 to the minus 3%, for example, then keep doing something. Now, of course, as you do this thing, you need to update your error. Otherwise, your while loop is going to go forever. So that goes to your statement. Okay. So here's a condition. I declare a variable called nmax equal 3, and then another variable n equals 0. While n is less than nmax, print n, and then augment n by 1. Okay. So as long as n is less than 3, I'm going to keep churning on this loop. Once n becomes equal to 3, then it automatically exits. Okay? So we combined a conditional statement and essentially a for loop. While loops are really, really helpful. Okay? Now, sometimes you need to do something special if the condition of the while loop is not satisfied. We will rarely have to deal with this condition. So what you can do is essentially, while the condition is true, do something else, do something else when the condition is no longer true. Okay? As an example, for loops are similar to while loops, except you specify what you're looping on. Rather than specifying a condition, the for loop essentially goes over items in a list. You know, for I going from 0 to 100, do something 100 times. Okay? For I, you know, going from 1 to 10, do something 9 times. Okay? Now, another cool thing in Python is that is the idea of iteratable objects. And that Python defines pretty much all lists, arrays, and all lists, tuples, and numpy arrays as iteratable objects, right? So, for example, one way to loop through an array is to say, let's say you have an array that has 4 quantities in it, okay? So you could say for I equal from 0 to 3, print element 0, element 1, element 2, and element 3 in the array. However, there's a faster way of doing this, and you say for item in my array, print the item. So you declare the value on the spot and you loop over it on the spot. So let's see if I have an example over here. Okay, this is a great example. I'm show you two ways. Okay, so let's say I have a list 1, 2, 3, 4, 5, 55, 54. Okay, and then now if I wanted to loop over this array, okay, and let's say I want to multiply each entry array by 2. Okay, how would you do it? You would say, you know, for I in, so forget about the range now function, but just give me a second here for I 0 to 4. So this would be your traditional loop. Let's say, hold on, print I. So we have 0, 1, 2, 3, 4. Okay. So let's go to 5. Okay. Okay. So print I. Okay. All right. So the traditional way of doing a loop would be if I wanted to go and multiply each entry in this array, in this list by 2, is you would create an index I, a counter that goes over a certain range. We'll define this function in a second. But know that this loop for I in range 0 to 5 is gonna give me 5 values of I, which are 0, 1, 2, 3, and 4. Okay, and then I use that index to access the elements in the array. Okay, so I would say print AI. So that is printing A0, A1, A2, A3, and A4. And then if I wanted to multiply each entry by 2, I would say, for example, AI is equal to 2 times AI. Okay? And then I'll print AI again. Okay, so it multiplied everything by 2. But there's a better way of doing this, and that would be for value in A, print val. What this does, so let's go and reset. Let's go and reset A. So what I did here is rather than having to create an index counter and then access the entries in the array through that index, I immediately access the values in the array by iterating over the entries in the array. I declared a variable on the spot called val, okay, for value in A. Just loop over all the values in A. The benefit of this is that I didn't have to worry about figuring out how large my array is, right? So in the previous assignment here, I need to know how big A is. So let's say if I wanted to loop over 7, it's going to throw an error because the index is out of range. So what I needed to know the size of the array so that I can loop the correct number of times. The beauty of the other approach is that you just iterate, and this applies to pretty much anything. Okay, and then you can do whatever you want with the value. You can multiply it by 2 and update the array, etc. Do whatever you want. Okay, so that's the value of this type of for loop. Okay. The other way, which I just defined, is to loop through a range using the range function. So the range function essentially gives you a sequence of numbers going from, here's the definition. The range function gives you a sequence of numbers going from n minimum to n maximum minus 1. So if you do range from 0 to 5, it will give you 0, 1, 2, 3, 4. Okay, and if you're in doubt, always go and print it. Okay, so you could say for I in range, 0 to 10, print I. It's gonna give you the numbers 0, 1, 2, 3, all the way to 9. Okay. All right. Forget about breaks and continues. Okay, so I'm gonna stop here, and I'm gonna start actually numerical methods. We will come back to functions as needed. But for your homework assignments, you're going to have to go through the rest of the slides. There's about 20, 30 slides left. Go through and try to understand them as much as you can, or at least expose yourself to those. We will come back to those once we start doing programming in class for examples in class and for the homework, and then you will learn with me in situ how we define functions, how we use modules, etc., and so on. Okay, because again, if I cover everything, you're gonna be like, what am I gonna use this for? Okay, so this is just enough Python to get us started, how to declare a variable, how to do a for loop, and then let's see what we can do with those.